Hey guys, today we're going to explore how to use the dYdX API, which allows you to access various bits of information from the dYdX platform. If you haven't already, check out my other videos on my channel on how to set up a market making bot on dYdX, and also just how to use the dYdX platform in general. We can firstly get started with the API by installing the Python wrapper that dYdX has developed, and you can do that simply by doing this pip install dYdX-version3-python, and that will get this dYdX3 module in, which to use you just need to simply import like I've done so. You also need to have web3 and pandas. We're going to import pandas to process some of the data. The first thing after you've done that is to initialize a client object like so. On this URL that I've shared here, you can go and read some of the documentation that they've written. There's a private API to access various things attached to your account, and also a public API, which is the one we'll be looking at today, where you can get some of the market data out of dYdX. So after you've initialized the client object, some things you can do are listed on the API documentation, as we can see here. So we can see there's a get markets object which returns some values about different markets, a get order book, get trades, and so on and so forth. So if we go back to our Python script, we'll try firstly the get markets function, and the first thing we will need to do is just code like so. And if we just run this script here, we can see that it's returned some JSON data with different information about each traded market on dYdX. So for example, AVAX, we can see the market's AVAX, it's online, various information about its step size, the minimum tick size, what the index price is, Oracle price, and so on and so forth. So to pass that data in a more readable format, we'll just put it into a pandas data frame like so. Probably didn't label that too clearly, but yep, you can see now that we've put it all into a data frame. We've got all these different perpetual contracts with different information that we might want to look at, and some things that are particularly interesting are the funding rate. That's usually quite important, and then you might use some of the other details for your own purposes. The next thing we can do is get order book data from dYdX. So we can do that firstly by, well, the first thing we need to do is import these things called constants, which essentially you need to do that for each cryptocurrency you want to deal with. So for example, if we wanted to take a look at Sol, you need to, or Solana, you need to load in the Solana constant like so. And then we can just initialize a order book data request. So we'll just call it order book. Now, one of the things that we will need to pass in this one is the market that we want, and that's the constant, so market underscore Sol underscore USD, and then I'll just print out our results like so. And there you can see we've got a list or a JSON object with all the different bid-ask orders in the stack. So here are the bids, above here were the orders, and we can see the price and the size at each level. The next thing you can do is get something called market statistics. And again, we're going to need to import constants. And if you don't want to import each and every market, you can just run this import asterisk, and that will import all the constants that are available in your wrapper that have been installed. So this one's called Market Statistics. And to do it, we'll need to call the get_stats class, like so. This time we will go with a different market. So go with Cardano. And in this one, you have to pass a day's parameter. And if we go into the documentation, you will see that there you can specify different day ranges, so 1, 7, or 30, but it defaults to 1 day's worth of data. So we'll just print out what we get. So you can see essentially the volume that's traded over the course of 1 day for the Cardano market, and how much fees have been paid in Cardano. The next function that's a bit more of use is actually funding data. So you can get the historical funding data for the dYdX platform. And a lot of people run what's known as, I guess, funding arbitrage. So they'll short a particular perpetual contract on dYdX and long that contract on another exchange and collect the difference in funding. So it's good to know what funding you could have previously got, or at least backtest the funding that you could have previously got to see if that strategy is profitable. So again, we'll need to import the constants. This time we'll get date time as well, because we want to look at the historical time series of the funding rates as well. We'll also import matplotlib just to plot the data that we're going to get. I'll just start and initialize an object to get the time now. And to do that, you need to put it in as an ISO format. And then, like previous, we're going to call the dYdX client. So call this historical funding, client.public.get_historical_funding. Like it. We'll do sol again. And this time, for this particular call, you need to pass the time that you're looking at, and it will give you 100 bars worth of data. So I'll just run this piece of code first to show you what I mean. So it's given us the latest funding rate, and then it's given us the last 100 hours of those funding rates. We'll just format that data, funding df, and put it into a Panda data frame. Call it historical funding. Just take a look at what that looks like. As you can see, just nicely formatted the JSON data. And if we want to plot this, what we need to do is actually convert all these numbers to numerics. So unfortunately, these are all strings. So the API only passes everything as a string. So we just need to convert everything firstly to a numeric. So we'll do that now. Pandas has a useful toNumeric function. Right, and we'll just use this on each of the different columns that we have. So price, we need to convert that to a numeric. This one we need to convert to a date time. So not toNumeric, we'll use to_date time. And we need to pass the format that the dates are in. So the format that they're in is year, month, day, and then a T, and then the hour, the minute, the second, and the millisecond. And we'll multiply the funding rate by 100 as well, just so we get it in percentage terms. And we'll just take a look at it as well. Cool. And there you can see same data frame just converted to numbers. Now we'll just plot it, and we'll just show that, and you can see that the funding rate for Solana was really nice. It was really high before, but as the system has delevered, we can see that the funding rates have slowly dropped back to something more normal, but still a pretty good funding rate on dYdX relative to other centralized exchanges. The last function I want to show is just the Candlestick data function, which just pulls out price data from the dYdX platform. So again, we'll pull out the constants that we need, and to call it, we need to use the get_candles. That will be client.public.get_candles. Market we need, we'll use Bitcoin. In this one you can pass a resolution, so hourly, daily. Let's see what we got. Yeah, hourly, daily, 4 hours, 30 minutes, anything you can get on TradingView, even 1 minute. So the resolution we'll use is, let's use 1 day. And that's it. We'll just, again, put it into a pandas data frame, and we'll take a look at how it looks. As you can see, it gives you the low, high, open, close of that particular day, the base token value, how many trades were performed in what US dollar terms, and the open interest of the actual contracts. So yeah, that's all I wanted to show today, and that's how to use the dYdX API to pull some data about public markets that you might want to use for your own code. Thanks, guys.